All right, this video is going to focus on identifying the key features of a parabola. Okay. So the parabola is the name that we give to the graph of a quadratic function. Okay, so in the last video, we saw that the graph kind of has a U shape to it. Okay. All right, so we already saw the axis of symmetry in the last video. So just to give you a visual, right, if this is a parabola, the axis of symmetry would be a vertical line that goes right in between the two mirror images, right? So the left side and the right side are mirror images of each other, and the axis of symmetry is the line that goes right down the middle. It splits the parabola in half. Okay? And so I guess we can write a little description. A vertical line that splits the parabola in half. And there's a formula to finding the location of this line, right? It's x equals negative b over 2a, where b and a refer to some of the coefficients from the quadratic function itself. All right. The vertexes is another concept that we saw in the last video. So if your parabola opens in this way, the vertex would be the low point. And if your parabola opened the other way, if it opened down, then the vertex would be the high point. Okay. It's important to note that the vertex is always going to occur somewhere on that axis of symmetry. It's going to be kind of in the middle of the parabola. Okay. So instead of calling it a high and a low point, which is, I mean, those terms are okay to use, the more technical terms are a maximum and a minimum point. So this is a minimum point, it's at a low point on the curve, and this is a maximum, it's at a high point of the curve. Okay. So the vertex is the maximum or minimum point on the parabola. Okay. The x-intercepts is exactly how it sounds. It's going to be the locations where our graph, our parabola, crosses the x-axis. Okay, so if we had, say, a parabola like that, it crosses the x-axis twice. Okay. There are cases when the parabola only touches the x-axis in one point, and yet there's still other cases where the parabola does not touch the x-axis at all. Okay. So these are kind of like the three scenarios, right? It could have two x-intercepts. It may have just one x-intercept, which is if the vertex lies on the x-axis. Or it could have no x-intercepts. Right? Sometimes the parabola is just kind of like floating above the x-axis. Right. The y-intercept is going to be where the parabola crosses the y-axis. So if we had a parabola like that, there would be a point, a location where it crosses the y-axis. Now it turns out that when your quadratic function is in standard form, that is y equals ax squared plus bx plus c, okay, the c coefficient is going to be the location of the y-intercept. Okay. So we would say 0, comma c is the y-intercept. The domain is the list of all values that could be used as inputs to the function. And so since a quadratic function is a polynomial, the domain is every real number. Okay. So all real numbers can be used as inputs. Okay, inputs are the x values. The range is going to be the list of outputs or y values that we get from the function. Okay, and this is going to depend on the specific function, right? Each quadratic function has a different type of range. All right, so let's explore these ideas with a few examples. So here, example number 1, we'll just start off graphing like we did in the last video, and then we'll use the graph to identify the intercepts and talk about the domain and range. Okay. All right, so the first thing I'm going to do is I'm going to rewrite this function so that I see all three terms, the second degree, first degree, and the constant term. All right, so this is x squared, or 1x squared, plus 0x plus 2, right? Second degree, first degree, and constant. Okay. Now I'll label the coefficients. That's my a coefficient, that's my b coefficient, and that's my c coefficient. And from there, we'll figure out the axis of symmetry. Okay, x equals negative b over 2a. That's negative 0 over 2 times 1, and that's just going to be 0. Okay. So 0 is going to be the value we choose for the middle of our table of values. Okay. And then we'll pick two integers just less than 0, so negative 1, negative 2, and then two integers just bigger than 0, positive 1 and positive 2. Now we'll evaluate our function using these 5x values. So we'll have negative 2 squared plus 2, negative 1 squared plus 2, 0 squared plus 2, 1 squared plus 2, and 2 squared plus 2. So I'm just going to relabel this f of x. And I'm just evaluating the function, and then so here's an expression, and then here I'll write the actual coordinate. Okay. So I could do all this in my head, but I just want to be more convincing, use the calculator. Negative 2 squared plus 2 is 6. Negative 1 squared plus 2 is 3. Okay, this one I can definitely do in my head. 0 squared plus 2 is going to be 2. 1 squared is 1, plus 2, that's 3. 2 squared is 4. 4 plus 2 is 6. Okay, just to speed things up a little bit. Okay. So now our table gives us 5 ordered pairs, which we'll now plot over here in the coordinate plane. X negative 2, y 6. X negative 1, y 3, x 0, y 2, x 1, y 3, and x 2, y 6. Okay, and so we see that definitive U shape, right? That's our parabola. All right, so now let's figure out the vertex. Okay. Our vertex is going to be that unique point in the middle of our curve, and so that vertex has coordinates 0, 2. Okay. 0, 2. All right. And then now we'll discuss these other things. So like the x-intercepts. Okay, so we're looking in this graphing area, where does our parabola cross the x-axis? And it doesn't, right? So this is not applicable, doesn't exist here. Okay. The y-intercept is going to be where our curve, our parabola, crosses the y-axis, right? And it happens to be the point that I've highlighted here, right? So that's at 0, 2, right? So we're going to write it as an ordered pair, okay? At the point 0, 2 is where our parabola, our curve, crosses the y-axis. Okay. The domain, right, is the list of all values we can use as inputs to this function. So I can plug any number I want into this. 0, 1, 2, 100, 1,000, 1,000,000, right? So all real numbers. Okay. And the range is going to be the list of outputs I get, right? So I know a few outputs, like I get 6 as an output, I get 3 as an output, I get 2 as an output, but what other possible outputs do we get? Okay. Well, the graph gives us an idea of the possible outputs. Okay. This graph represents an infinite number of points, right? So there's points everywhere along this curve, and each point has its own y-coordinate. Okay. So it looks like we have some really big y-coordinates, and looks like the smallest y-coordinate we ever get is for our vertex. Okay. And so we could think of it as on the y-axis, right, the lowest that we would ever get to is that point there, okay, which is a y-coordinate of 2. Okay. But we get y-coordinates much bigger than 2, even just a little bit bigger or moderately bigger. Okay. But this parabola only contains points whose y-coordinates are 2 or more. Okay. So we could say the range are y-coordinates that are greater than or equal to 2. Okay. We would never get a point whose y-coordinate was less than 2, right? Because the curve doesn't exist down here. The curve only exists kind of in this region here, right? Where on the y-axis you can see is values 2 and more. All right, so that was a bad idea to put the second page right underneath the first, because now I've got ink that bled through, but it's not too bad. All right, so our next function is, again, quadratic, x squared plus 2x plus 1. Okay, I'll fill in the first coefficient, which is a 1, and just label everything. All right, so that's our a coefficient, our b coefficient, and the c coefficient. So using our trusty formula, x equals negative b over 2a, we will determine the axis of symmetry. That's going to be negative 2 divided by 2 times 1, and that's going to be negative 2 divided by positive 2, so negative 1. So the middle value, the middle x value for our table is going to be negative 1. Okay. And then we'll choose 2 integers just less than that, so negative 2 and negative 3, and then we'll choose 2 integers that are just bigger than that, so 0 and 1. Okay. All right. And then now we're going to evaluate. So let's see, negative 3 squared plus 2 times negative 3 plus 1, negative 2 squared plus 2 times negative 2 plus 1, negative 1 squared plus 2 times negative 1 plus 1. You get the picture. All right, so negative 3 squared plus 2 times negative 3 plus 1, okay, is 4. Negative 2 squared plus 2 times negative 2 plus 1 is 1. Negative 1 squared plus 2 times negative 1 plus 1, 0. Okay, 0 squared is 0, 2 times 0 is 0, so this is just going to be 1. 1 squared is 1, 2 times 1 is 2, 1 plus 2 is 3, plus 1 more is 4, and I have that kind of symmetry here, 4 and 4, 1 and 1, and then 0. Right, so x negative 3, y 4, x negative 2, y 1, x negative 1, y 0, x 0, y 1, x1, y4. Okay, so that's our distinctive U-shaped parabola. Okay. All right, our vertex is that unique point in the middle. Okay. And it matches up with the middle row of our table of values, so that's negative 1, 0. Okay, the x-intercepts, right? So where does our parabola cross the x-axis? Well, you can see it meets right there, right? The vertex is also an x-intercept. Okay, so that's going to be negative 1, 0. Okay. Y-intercept, okay? Where does our parabola meet up with the y-axis? Okay, let's color code this one. Okay, so our y-intercept is going to be this green point right there. Okay, so that's the fourth point, so I can look in the table and go to the fourth row. It's 0, 1. The domain is all real numbers because I can use any real number I want as an input to the function. So all real numbers. Okay. And then the range is going to be the y values, or the outputs I get for that function. I know I get 0 as an output, I get 1 and 4. Okay. But what other outputs do I get? Well, any point along this graph tells me what an output value would be if I look at its y-coordinate. Okay. So if I just kind of highlight where my graph exists, okay, my graph exists above this horizontal line. Okay. And if I look at the y-axis, right, the part of the y-axis that's being highlighted is every value that's 0 and bigger. So according to our graph here, it tells us that the y-coordinates of this function are going to be numbers that are 0 and bigger. Okay. This function does not produce points down here. It does not produce points with negative y values. It only produces points with positive y values. Okay, the last problem is a U-try, so I would encourage you to just pause the video, try this one on your own, and then unpause when you're ready to check your answer with me. All right, so I'm going to go ahead and put the coefficient of negative 1 there and label these. This is my A, my B, and my C. Okay, so x equals negative b over 2a. It's going to be the negative of negative 4 divided by 2 times negative 1. So that's 4 over negative 2, so negative 2. Right, and that's going to be the center middle value in our table. And we'll choose some integers that are just less than that and just bigger than that. All right, so let's see here. We're going to have to evaluate now, so the negative of negative 4 squared minus 4 times negative 4 minus 4. The negative of negative 3 squared minus 4 times negative 3 minus 4. The negative of negative 2 squared minus 4 times negative 2 minus 4. Okay, negative 4 times negative 1 minus 4. 0 squared, 4 times 0 minus 4. All right, that's a lot of math to do. All right, I'm going to pull out the big guns here because this calculator allows me to kind of recall certain commands I've already written. So we're going to do the negative of negative 4 squared minus 4 times negative 4 minus 4. Okay, so that produces an output of negative 4. Okay, and then I'll change everything to negative 3's now. Okay, so that gives us an output of negative 1. Okay, and then we'll change those inputs to negative 2's. Okay, and that produces an output of 0. Then I'll change it to a negative 1. Get negative 1, and then finally we'll change it to 0. we get negative 4. All right. So let's plot these now. Negative 4, negative 4. Negative 4, negative 4. Negative 3, negative 1. Negative 2, 0. Negative 1, negative 1. And 0, negative 4. All right, so our vertex is going to be that unique point there at the highest location of the parabola, right? So negative 2, 0. Okay. The x-intercept is going to be where we cross the x-axis. Here, let me label it. So there's our x-axis, and it hits the parabola at that point only, right? At the vertex. Okay. Negative 2, 0. The y-intercept. Okay, so let's trace down the y-axis until, boom, right there, we hit the parabola. So that's going to be at 0, negative 4. It was the fifth and final value. 0, negative 4. Okay. The domain, all real numbers. Okay, and then now for our range. Okay, so the range is the y-coordinates that are produced. And so right now I only have 5 points that are easily identifiable on this curve, but there's hundreds, millions of points, trillions of points, okay, all on this curve, right? And they just keep getting lower and lower and lower. Okay, so if I just kind of shade where the curve exists, right, the curve exists below that line, right? And so on the y-axis, right, if this number line had labels on it, right, you'd have 0, negative 1, negative 2, negative 3, and then it would just keep getting more and more negative. Okay. So the y values that exist on this curve are 0 and smaller. Okay, so we would say the range are y values that are less than or equal to 0. All right. Thanks for watching. So good luck on your assignment. Feel free to email me if you have any questions.